Let's do another example. Starting with the domain, we want to look at the denominator and set that equal to 0 and solve for x to find out which values have to be excluded from the domain. Now this one's a quadratic equation, but it's not already factored for us. So we have some choices about how to solve it. We could go ahead and factor this. We could graph it and find the x-intercepts, or we could use the quadratic formula. I'm just going to factor it. This is going to factor as x minus 2 times x plus 1. So then my two solutions are x equals 2 and x equals negative 1. These are the numbers that have to be excluded from the domain. If I want to write my domain in interval notation, that would be negative infinity to negative 1, and then negative 1 to 2, and then 2 to infinity. Now for my x-intercepts, this time I'm taking the numerator and setting it equal to 0. And this one is also a fairly complicated quadratic equation, but this one doesn't have an x term, so I'm going to try using the square root method to solve this. If I subtract 8 from both sides, then I have negative 2x squared equals negative 8, and if I divide both sides by negative 2, that gives me x squared equals positive 4. Now I can take the square root of both sides, and I'm going to end up with x equals plus or minus 2. That gives me two x-intercepts, one of them at negative 2, 0, and the other one at positive 2, 0. One thing we always have to watch out for, though, is those holes in the graph. And if I look at these two values, the 2 is actually one of the ones that was excluded from my domain. So I'm going to have to throw out this x-intercept, and instead of an x-intercept there, or a vertical asymptote, I'm actually going to have a hole in the graph at x equals 2. I could go ahead and say that there's a hole in the graph at x equals 2. If there's a hole, there can't be an x-intercept there, and there also can't be a vertical asymptote there. When I find my vertical asymptotes, that means I only have one vertical asymptote at the other value that was excluded from the domain, and that's at x equals negative 1. Then last, for my horizontal asymptote, the degree on the top of this is 2, because I have an x squared. Also on the bottom, I have degree 2. So now I have to find my two leading coefficients and divide them to find my horizontal asymptote. My leading coefficient for the top is negative 2. My leading coefficient on the bottom is a positive 1. That means my horizontal asymptote is y equals negative 2 divided by 1, or just y equals negative 2. I'm going to take all the information I already have and add it to my sketch before I put this into my calculator. I have an x-intercept at negative 2, 0. I have a hole in the graph at x equals 2, but I can't really put that in there yet. All I can do is write a note to myself on the graph to remind myself that there's going to be a hole where x is equal to 2. But it's hard to tell exactly where that is without using the calculator. I do have a vertical asymptote at x equals negative 1. I'm drawing in a dotted vertical line at x equals negative 1. And then I have a horizontal asymptote at y equals negative 2. I'm going to draw in a dotted horizontal line at that location. Now I'm ready to graph this with my calculator. For this one, because both my numerator and denominator have more than one term, I'm going to have to put parentheses around each one in order to get the correct graph. The reason that I sketch this on paper first is that I want to make sure this matches with what I see on my calculator graph. If they're a lot different, then I either put the function into my calculator incorrectly, or I did something wrong on paper when I was finding all these different features. But I can verify from the graph that I do have an x-intercept at negative 2. I can see that crossing the x-axis there. And I can see the behavior I would expect around a vertical asymptote. on either side of the line x equals -1. I can also see on the two ends of the graph that my graph looks more and more like a horizontal line, and I can see that it's getting close to something that's below the x-axis, and I was supposed to have a horizontal asymptote at y equals -2. So what I'm seeing there fits with what I already found here. Now I can fill in the graph from what I see on my calculator. And as I'm doing this, when I get to the part of the graph where x is equal to 2, I have to remember to put the whole in. So as I get close to the vertical asymptote on this side, my graph is going up towards infinity. On the left end, my graph is going down towards the line y equals -2. And then on this side of my vertical asymptote, my graph is going down towards -infinity. And now I'm going to draw this along, and when I get to the point where x would be equal to 2, I'm going to put a hole in there. So that's going to look something like that, and then I'm going to continue the graph on that way. And as I keep going this way, my graph is going to get closer to the line y equals -2. So this is where my hole ended up being.